Okay, I'm going to discuss chromatography. So I'll be sharing this slide. What you have actually practiced in the lab is paper chromatography. So in general, chromatography is a physical method of separating two components or more in a mixture by distribution between two phases. So from the word chroma, actually it means color. So it's like color writing chromatography because it was discovered by a botanist, a biologist actually, who tried to separate pigments. And through different mixtures, he was able to separate the pigments. That's why you have color. There are different pigments in the chromatogram, so that's why he called it chromatography. Anyway, what we did in the experiment was use paper and a solvent. So in the experiment, we used 50% isopropyl and 50% water, but it's not actually so actually the alcohol mixture that you buy is already 70% alcohol, so it's not accurately 50%, so a little lower than that. But we used that to create the mixture for the solvent. So the chromatographic process occurs due to the differences in the distribution constant of the individual sample components. So in plain English, well, basically you have different interactions, different solubility in the solvents. Because of these different interactions of the molecules, they will move in different speeds. Okay, so it is a technique used to separate and identify the components of a mixture. In your experiment, it's the red and blue ink. It works by allowing the molecules present in the mixture to distribute themselves between a stationary and a mobile medium. So their intermolecular interactions of each molecule in the mixture will be different because they will interact differently with the solvent and they will interact differently with the paper itself. So molecules that spend most of their time in the mobile phase are carried along faster. Okay, so that's chromatography. So according to the mobile phase, there are actually many types of chromatography. You have liquid chromatography, where your mobile phase is a liquid, and you have also you can have a solid stationary phase like LSC. LLC is actually liquid chromatography is where your uh, stationary phase is bound to a solid substrate. Well, basically, you have many different types of chromatography. Gas chromatography is, of course, one of them. So you use gas as the mobile phase. So you have gas solid chromatography and gas liquid chromatography. You also have TLC or thin layer chromatography. The stationary phase is a thin layer supported on glass, plastic, or aluminum plates. And of course, the experiment that we did, we used paper chromatography. The stationary phase is a thin film of a liquid supported on an inert support, so like paper. And also column chromatography, where you in a glass column you put a material where the stationary phase is that solid material and you allow a solvent to pass through. Okay? So ito pabaliktad kasi you're pouring the solvent. So you're separating the mixture on the way down. So sa paper chromatography and thin layer chromatography, you're allowing the solvent to go up. So in most cases, we use paper chromatography and thin layer chromatography for determining what are the components of the mixture and figuring out what uh, what is the best solvent. So you try to do trial and error for you to separate the components of a mixture. And then you can do that in a large scale in a column chromatography. But we'll concentrate on paper chromatography since that is the experiment that we did. We also have adsorption chromatography, partition chromatography, ion exchange chromatography. So there are lots of chromatography uh, that is available out there. So related to paper chromatography is the thin layer chromatography. So it's a method of identifying substances and testing the purity of compounds. So it's a useful technique because it is relatively quick and requires small quantities of material. So you separate them by using a stationary phase and a mobile phase. So you distribute a mixture of two or more substances there. So in this case, the stationary phase is a thin layer of adsorbent. So you use silica gel or alumina. And you have the mobile phase. It is a developing liquid which travels up the stationary phase. So this is the solvent. So because of the intermolecular interactions, the components of the sample will separate on the stationary phase. So it depends on how much they absorb on the stationary phase versus how much they dissolve in the mobile phase. Okay, so it's similar to paper chromatography. So you have the solvent here. We did paper chromatography because it's the cheapest, the one we can do at home. That's why I decided to use that type of chromatography. But the principle is also similar. So you have the solvent here, and then you have this spot on the plate, and then you allow the solvent to rise through the plate. Okay, so and then you stop, and then you measure the RF values. Okay, so you have the solvent like paper chromatography. So make sure that the spot is not uh, uh, does not touch the solvent. So when you allow the solvent to rise, nangyari dito? Sana nag-rise siya. Rise sana to eh. Hindi nag... Anyway, I look for another site where I can show you yung RF value, how to calculate the RF value, which will be part of your exam. So the RF or retention factor value for each pot should be calculated. So it is different for any component. So it is characteristic for any given compound on the same stationary phase using the same mobile phase for development of the plates. Hence, known RF values can be compared to to those of unknown substances to aid in their identification, meaning because of their unique properties in the solvent that we can identify what components we have. So kung may previous data na yung sa isopropyl alcohol, yung RF values niya is 0.75, tapos may nahanap kang component na baka may kung baka may nakita kang mixture, tapos may nahanap kang compound na ganun din na value, baka same yung substance. Okay? Okay, so it's not that accurate compared to other methods kung paper chromatography lang gamitin mo. Pero it's one way to find out. So it's a possible way to identify a known substance. Okay, so yung RF value, so sa numerator, it's the distance from the start to the center of the substance spot. Okay, so yung na-travel nung color, nung ink in our case, no? So hanapin mo yung center spot. Tapos yung sa denominator, distance from the start to the solvent front. So ibig sabihin kung saan pinakamalayong mag-travel, no? Yung solvent. So take note, dahil yung solvent yung umaakyat, hindi pwedeng lumampas yung mga spots natin. So yung RF value mo is always equal or less than 1. So hindi dapat lalampas ng 1. Okay? So may ruler ka, may measure mo yung distance niya dito. So maghanap ako ng ng mga experiments na simulation na to explain to you how RF values are calculated. So RF values often depend on the temperature and the solvent used in the TLC experiment. So similar to paper chromatography. So the most effective way to identify a compound is to spot known substances. So these are authentic next to unknown substances on the same plate, sorry. Okay, so parang kino-compare natin. Kung ba alam natin na nandun yung component, we know the RF value. So masaspot mo yun sa mismong chromatogram or yung paper or TLC. In addition, the purity of a sample may be estimated from the chromatogram. An impure substance will often develop one or two or more spots. Yung pure sample kasi made up of only one molecule. So that means only one type of intermolecular interaction. So hindi magsa-separate yun. So in principle, the components will differ in solubility and in the strength of their absorption to the absorbent. So in our case, it was paper. In this case, it's the thin layer, silica. And some components will be carried farther up the plate than others. So ganun yun. Yung intermolecular forces, dun sa stationary phase at saka mobile phase, nag-interact para kung gaano kabilis yung movement nung mismong molecule na yun. When the solvent has reached the top of the plate is removed from the developing chamber and dried, and the separated components of the mixture are visualized. So, ganun din sa paper chromatography, no? We dry them and then we look at the components. Kasi nga may color yung ink, wala tayong problema dyan. Okay? So, if it's colored, makikita agad kung saan yung yung pigments. Pero pag hindi, Kasi yung mga organic compounds, madedetect yan ng UV lamp. So, using UV lamp, ma-visualize mo yung plate. So, sa paper chromatography, so same concept, no? So, dahil wala tayong filter paper, we use bond paper. Pero, same naman yung principle nun. So, the factor governing the separation of mixtures of solids on filter paper is the partition between two immiscible phases. So, yung water absorbed on the cellulose fibers, yun yung stationary phase. Ay, sorry. Ang sa cellulose fibers mo, yun yung sa stationary phase. Sorry to Yung organic solvent, ito yung mobile phase. Sorry, nagkamali ng type. Kasi may konting moisture yung cellulose fibers, no? Kaya medyo, dahil moist siya kahit wala ka pang nilalagay, medyo moist na yung uh, paper due to the environment. And then meron kang mobile phase na yung mixture natin. So, pinaghalo natin isopropyl at saka water. So, ideally, dapat kino-cover nyo ng mabuti yung kasi gusto mo mag-stabilize yung ah, yung vapor pressure dun sa loob. So, ang mangyari pag ginagalaw mo, gagalaw yung solvent, hindi siya tataas ng sabay-sabay. Okay, maapektuhan yung paggalaw ng mga spots mo. Okay? So, saan pwede magkamali, no? So, ginagalaw nyo or hindi nyo tinatakpan mabuti. Yung makaka-apekto yan sa pag-akit ng solvent. Okay, so ganun yung principle niya. Ito, sana may kulay. Hindi pa napakita yung ibang version ng to. Sayang. Usually may animation yan. Okay. So, nag-try tayo ng isang simulation. Meron akong simulation dito. So, i-share ko to. So, wala kasi to sa manual, pero importante kasi to. Ginagamit to talagang technique sa biochemistry. So, I decided to still include it kahit wala sa manual. Okay, so ito yung ginawa nating experiment, no? So, ayan yung site. Hanapin nyo lang yung paper chromatography simulation. So, your mixture is the red and blue ink, no? So, gagawin natin itong experiment na to. Okay, so kunyari, ito yung mga experiment namin before magka face to face, no? So, ito yung ginawa na namin nung dati sa mga students. So, may mixture talaga siya na red and blue. So, magkahalo na. So, kukuha ang konti. Pag magkakulay na, ibig sabihin meron na. Buksan ko to. Pasok ko yung lagay ko na yung spot dun sa paper, no? Sasabit ko. Ayan. Tapos close ko yung lid. Okay, so as time goes by, kita mo umakit yung solvent. Nag-separate yung red and blue ink. So, blue yung dapat nasa taas. Mas mataas dapat yung RF value ng blue versus red. Okay? So, dito sa experiment, meron kang ruler. Labas na natin to para magkaroon ng ruler. So, may ruler ka, ayan, in centimeters. So, ano yung RF value niya? So, tingnan natin yung solvent, no? Yung solvent mo, 5 centimeters yung movement. Tapos yung blue ink, 4.9. Okay? So, 4.9 yung ano. Teka lang, calculate natin, ha? So, bali ang distance traveled by the solvent is 5 centimeters. Tama. Tapos distance traveled by the blue ink is 4.9. Tama. Okay. Distance traveled by the red ink. So, ito ay 4.4. Okay. So, tama. Yun yung distance traveled, no? So, ang RF value natin for the blue ink, teka, ano ko to, 4.9. 4.9 divided by 5 is 0.98. Okay, tama. So, anong value for the red ink? 4.4 divided by 4.9. 5, sorry. Is 0.88. Okay, tama lahat. Okay, gets? So, yan yung experiment natin, no? So, lalabas yan sa quiz natin. So, madali lang. Di-divide nyo lang yung distance traveled by the solute or kung anong spot na may kulay. Tapos, divided by the distance traveled by the solvent. So, take note, pag di gumalaw yan, so 0 yung distance traveled by the spot. So, 0 yung RF value mo. Kung kasing bilis lang ng solvent, so ang highest value niya will be the distance traveled by the solvent. So, 1. So, ang range lang na possible value is 1 to 0. So, walang pwedeng lumampas. Okay? Okay, try natin yung try natin ang wait. May isa pa tong So, yan yung paper chromatography, pero meron pa tong isang experiment eh. Meron pa tong possible. So, pwede kang gumamit ng spinach leaves. So, meron kang pigments yan. So, ganun din yung principle, no? So, ilalagay nyo lang yung ink, yung pigment, ilalagay nyo sa spot. Yan, buksan nyo. Sabit nyo. Okay, ganun din. Kasi yung plant pigment na to may kulay. So, walang problema. So, paano yung walang kulay? Pag walang kulay, gagamit ka ng UV light. Or may mga chemicals yan. Depende kung anong mga substances. Like amino acid, for example, may specific na chemical na i-add ka dyan para magkakulay or ma-distinguish mo yung spot. Kasi, syempre, kung walang kulay, paano mo malalaman kung saan siya? So, ganun din yung principle, no? So, hindi ko na i-compute to. So, ayan. So, meron kang pigment, chlorophyll B ka, chlorophyll A, xanthophyll, o tsaka yung carotene. So, ganun din yung principle, no? So, di-divide mo lang yung, kukunin mo lang yung value nung solute, nung distance traveled by the mismong pigment or solute, plus divided by the distance traveled by the solvent. Okay, so madali lang naman yan. So, punta tayo dun sa experiment. So, meron kayong kahit ordinary water lang, kahit sa yung distilled water na mabibili sa 7-Eleven. Yung alcohol naman. So, nasa paper cup. Tapos, suspend the paper vertically. Pwedeng jar, pwedeng paper cup. So, ganun din yung principle, no? So, nakita ko nakasagot naman yung iba sa inyo. So, nagets niyo yung principle ng RF value. So, what is responsible for the movement or separation of the pigment of the ink? Okay, to simplify, pwede mo sinabihin intermolecular forces between the solvent and basically the stationary phase and the mobile phase, no? So, pwede mo sabihin um, it is the solubility in the mobile phase and the molecular interactions with the stationary phase. Okay, so yung key principle dito sa chromatography, stationary and mobile phase. So what is the difference between the stationary phase and the mobile phase? So from the word stationary, hindi siya gumagalaw. Tapos yung mobile phase, yun lang yung nag-move. So ito yung solvent. So sa paper chromatography, yung ano mo, is yung mobile phase mo is yung solvent mismo. Tapos yung stationary phase mo is yung paper mo with, syempre may mga water component ka na din doon. Okay. Okay, so applications of chromatography, I've already discussed this. So kasama na rin yan. Applications sa biochemistry, yung mga paggamit sa pag-separate ng amino acids, pag-separate ng proteins. Actually, yung gel permeation, yung electrophoresis, type siya ng chromatography kasi sineseparate mo siya by the electrical field. So basically, separation of mixtures yan. So you have also yung mga chemicals na yan dahil nga sa biochemistry different yung mga isomers mo, kailangan ma-separate ng chromatography din yan. Diba? So may mga stereoisomers ka, may enantiomers ka, you need to separate them. So that's important. And also the different types of chromatography being used in biochemistry. You have na-discuss ko na rin yun sa PowerPoint. Okay? So I guess that's it.